Okay, so you need help on your operations with complex numbers homework. I'll go through all these questions with you. I might not complete all of them, but I'll at least show you how to do each type and let you kind of work out the rest. All right, so graph each complex number. This is pretty easy. So the complex graph that we have, there's a real axis, which is essentially our x-axis, right? And then we also have an imaginary axis, which is technically our y-axis. So we're going to plot these. We're going to plot the real numbers we'll follow the real axis for that, and then the imaginary numbers will follow the imaginary axis. Okay. Now keep in mind that this graph on your paper is actually going up by twos. You have 2, 4, 6, 8, and -2, -4, -6, -8, and so on. Even the y-axis, you have 2, 4, 6, 8, 10, right? And then -2, -4, -6, -8, -10. The real axis and imaginary axis. They're going by 2. Number 1 is -6. Well, the first question, is that a real number or an imaginary number? It's pretty easy to tell the difference because imaginary numbers have I on them, real numbers do not. So that's a real number because there's no I. So I'm going to plot -6 on the real axis. So the real axis, again, is our x-axis. -6 is right here. And there we go, that's it. Because there is no other part to do it, I just need to plot that on the real axis. Number 2, 4i, you're going to plot 4i on the imaginary axis. So on your imaginary axis, go ahead and find 4i and put a point there. I'll let you handle that. Number 3, 6 plus 7i. So we've got two parts. I've got a real part and an imaginary part. But let's just follow our process. 6 is a real part. So we're going to go to 6 on the real axis, right, which is over here. But then I have to go up to 7i on the imaginary axis. So I have to go up to 7i, which is going to be here. So this is the point 6 plus 7i. Because it matches at 6 on the real axis, it matches 7i on the imaginary axis. So that point is 6 plus 7i. So that's how you're going to do number 4 and number 5 as well. Just follow -8 on the real axis and then go down to -5 on the imaginary axis. So you'll have your point. Okay. Now number 6, 7, and 8. There's just a formula that you need to know. And your formula is that the square root of a plus bi is equal to the square root of a squared plus b squared. So here I've got the square root of a plus bi. So this is equal to the square root of 4 squared plus 2 squared. Notice it's not 2i squared, okay? It's just the b number, just the number 2 here is squared, not 2i. Right? And you just kind of, square them and then add them together. So this would be the square root of 16 plus 4, because 4 squared is 16, 2 squared is 4, which is the square root of 20. And I'll let you guys simplify it, but make sure you simplify that answer. Number 7, same thing. Just keep in mind this is a -1i. So you're going to use that formula, a squared plus b squared. A is your 5 and b is your -1. So this would be 5 squared plus -1 squared. Now keep in mind, if you square negatives, it's probably just good to do this in general, but put your numbers in parentheses. It's just going to make sure you don't mess it up. 5 squared is 25, and 1 squared is 1, so this becomes the square root of 26, right? Just keep adding them together and then simplify your square root at the end. Alright, 8 does not have a real term, but it's okay, just keep that formula in mind. That real number would just be 0. Now, for numbers 9, 10, and 11 here, we're just basically, when we're adding and subtracting, that's a key phrase here. Oh man, I gotta fix that. When we're adding and subtracting, we're simply just kind of adding and subtracting like terms. So, real numbers together and imaginary numbers together. Don't really focus too much on the parentheses. They're not entirely important for adding purposes. I mean, they kind of are, especially when it comes to subtracting, but just combine your like terms. For number 9, I'm adding, so I'm just going to add my like terms. So I have -1 plus 6. So combine them, -1 plus 6 is 5. Right? And then I also have 2i minus 9i. 2 minus 9 is negative 7, so I'll have negative 7i. So there's my answer, 5 minus 7i. Now the trick is though, and the only catch you have to be careful with, is number 10, when you're subtracting, what I do is I distribute my negative first. Okay, and then I will combine my like terms. So I'm going to distribute my negative. This becomes a negative 4 and then a negative 7i. Okay, I'm going to leave the first. I didn't have a negative to distribute for the first group, so it stays the same. But that's what I'll do. Distribute the negative and then combine your like terms. So 3 and negative 4 can combine, and then you have your negative 3i minus your 7i can also combine. Alright, number 11, again, combine your like terms. You're adding, so there's no negatives to distribute. You should be okay. Number 12, 13, and 14, you're multiplying, which means distribute, pretty much. So in number 12, you have 3i times 2, which is going to make 6i, and then 3i times negative 3i. So 3 and negative 3 make negative 9. Don't forget though, I times an I makes an I squared. And the catch we really have to remember in all of these, anytime that we multiply, is that I squared is equal to negative 1. So anytime you get an I squared, go ahead and just change it to a negative 1. Okay? And then you can finish your problem from there. So that's going to be negative 9 times negative 1, which makes a positive 9. And there's my answer. The proper way of writing this would probably be 9 plus 6i, considering the fact that you do want your answer to be in the a plus bi form, so the real number first and the imaginary number second. But anyway, number 13, you're also distributing. So 4 times 2, it's going to give me 8. 4 times I, which would give me 4i. And then the 5i. 5i times 2 would give me 10i. And then the 5i times I would give me 5i squared, because don't forget I times I makes an I squared. Now again, because I see that I squared, I have to remember that I'm going to just change that to negative 1. Okay? Anytime you have I squared, change it to negative 1. So let's just bring everything down for the meantime. And then I can multiply 5 times negative 1, which is going to make a negative 5, of course. So I'll have 8 plus 4i plus 10i minus 5. And combine your like terms. You probably could have combined these earlier, but you can certainly combine those terms together. And you can also combine the 8 with your minus 5 as well now. Okay? And number 14 is the same thing. You'll just distribute and make sure you convert your I squared to negative 1, and then combine your like terms. Now, for number 15 and 16, to simplify, you're going, for any time you have this I in the denominator, you have to multiply the equation, the top part and the bottom part, by the conjugate of the bottom. So we just previously talked about conjugate. Conjugate is when you change the the sign for the I term. So this is a positive 3i. But the conjugate would be changing the sign for that, so its conjugate would be a negative 3i. And I'm going to multiply the top and bottom by that same negative 3i. Put parentheses around this just so it's a little bit neater. And it's basically like you're distributing. The 2 times your negative 3i would make a negative 6i, and then your 4i times negative 3i would make negative 12i squared. Over 3i times negative 3i would be a negative 9i squared. Because remember, the i's make I squared. Now, before I do anything else, I'm just going to change these I squareds to negative 1s. So I have negative 6i minus 12 times negative 1 over negative 9 times negative 1. So all I did was change the I squareds to negative 1. And then you can just kind of finish it off from there. The negative 12 times negative 1 make a positive 12, so it's become negative 6i plus 12. And then on the bottom, I'll have a positive 9, because negative 9 times negative 1, positive 9. And at the very end of this problem, I'll look at all 3 of these terms and think, can I reduce them? The 6, the 12, and the 9 are all divisible by 3. So if you divide all of them by 3, you'll have negative 2i plus 4 divided by 3. Alright, because negative 6 divided by 3 is the negative 2. The 12 divided by 3 is 4, and then the 9 divided by 3 is 3. So that's your total simplified answer. Now for number 16, I won't work the whole problem out, but the conjugate of 4 plus I is 4 minus I. So you're going to have to multiply the top and bottom by 4 minus I. I put parentheses around this so it makes it a little easier, but you're going to have to distribute, just like you did in previous problems right above this, distribute those, and then make sure you simplify your I squareds, and distribute the bottom as well. Make sure you simplify your I squareds, and just simplify this until you're done. Now, for number 17, I to the 11th power is the thing that we're concerned with. Now, when you have I to a certain power, you have one of 4 possible outcomes. You either have I, negative 1, negative I, or positive 1. I to the first power is a regular I to the second power is equal to that negative 1, I to the third power is equal to negative I, and I to the fourth power is equal to positive 1. And then when you try to go to I to the fifth power, this pattern repeats itself when you start back at I again. So, this pattern would go I to the first power, I to the second power, I to the third power, be that negative I to the fourth power, and it would repeat. This would be I to the fifth, this would be I to the sixth, that would be I to the seventh, this would be I to the eighth. Then it would repeat. This would be I to the ninth, I to the 10th, I to the 11th, I to the 12th. And then it keeps going over and over again, repeating these 4 terms every single time. So the idea is, what are you going to be when you get to I to the 11th? You can just write them all out 11 times and see which one ends up being the 11th term. Or my way of doing it, especially when it's a really big number, is take the number, whatever it is, in this case it's 11, and divide it by 4. If you get a result that ends as a 0.25, then it's going to be I. If it ends in 0.5, it's negative 1. If it ends in 0.75, it's negative I. And if it ends as a whole number, it's a positive 1. So 11 divided by 4 would give me, I believe, 2.75. So since it ends at 0.75, I to the 11th is actually, what's 0.75? Negative I. Okay? So I would just put them together. 2 times negative I is going to make a negative 2I, and that's going to be the end of it. Alright, now the last one, number 8, it says sum of individual impedances, which means if you have this one and you have this one, and what's the total, then you're just adding them together. So that's one where you just kind of add if they're like terms, and you've got your final answer. So just add those 2 together, and you'll be done. Alright, that's going to be it for this video. I'll see you in another one. Sayonara.